Hey everybody, thanks for taking some time out of your day to come and listen to us talk about some of the things that we've learned about GraphQL over the last quarter. My name's Austin, and I'm on the SWAT team, and Ryan is the lead over on the profiles team. And this is going to be an introduction to GraphQL. So bottom line up front, our goals for this after you finish the presentation is to have a better understanding of all of the concepts, toolings, and pros and cons that we've learned over the last quarter. And some of the conclusions we've made, we think GraphQL is superior really to REST for grabbing data and being able to pull it down in a way that's sustainable. And mutating data is also slightly better than like a traditional REST system. So agenda, first thing we're going to do is demonstrate some of the pain points that we've ran into with REST over the years. Then after that, Ryan's going to take over and talk about GraphQL, go over some of the base concepts like queries, and get into more of the advanced concepts, abstract types, aliases, modifiers. Then I'll circle back and go over some mutations and some of the tooling, and then Ryan will finish off with some other tooling. Then we'll do questions at the end. All right, so at the end of the day, what we do as a company is we have a bunch of domain logic. And what we're trying to do is find a way to deliver that domain data to clients in a way that's usable. And the example that I'm going to run through is going to be users, so like doctors that have locations, whether those are like institutions or hospitals, and then those locations have an address. And as it relates to Doximity, we're really talking about getting data into a user interface over the internet, especially as we're moving more away from server rendered pages to more of like a single page app-like experience. And this is an example of the profiles page. And the data that we're talking about getting here, I've just had some arrows over to is, you've got user information at the top, you got some locations there towards the middle that also have an address, and then you've got a summary down at the bottom. So how does that look in traditional REST? So, the most like scarecrow-like approach you could have would just be have a single layer of access for each of the resources. So you could request a user, you could request a location, or you could request an address. And where this gets more complicated when you're talking about a client accessing data, whether that's mobile or a single page application, is how do you get the location IDs to the client? You're going to have a user that's probably logged in, you got their ID. So you have to make a bunch of decisions. And then if you decide to go in this REST-based approach where you've just got a single layer of resources, you're going to have to do a series of requests in order to accumulate all that data to populate what we've got here on this view. And the way that would maybe look is kind of awful, but this is probably something a lot of you may have done with promises or callbacks. You're going to fetch some user, and then hopefully you got React or Redux or like Vuex or something so that you can just dispatch out that data. And then you're going to do a bunch of requests for locations, and then you're going to consolidate all of those. And then once you finally got the locations, you're going to do a request out for cities or locations. So, it's been going like this for a really long time. So there's nothing like wrong with this. It's just not optimal, and it can be kind of painful from a front end perspective. So the next step for that really isn't a ton better. It does give you a little bit more, and that's where you start to nest the resources on top of other resources. So, users, that you've got a user ID, so you can just request straight from locations based off of that nested resource. Whenever you start doing this, you start to have to deal with other problems that are equally as hard, like how much data do you send down? What if you just have a user ID and you want to request locations? Do you request user ID locations and then do another promise to request the user data? It cleans it up just a little bit, but still you have to do multiple promises. You got a lot of places where stuff can break in the request response cycle. And not to mention, like, if you have a huge data set, It's pretty easy to DOS, especially like a Rails server, if you have like several hundred things that you're requesting simultaneously. Note, I have done that before, so yeah, something to be careful of whenever you're doing multiple of these. So here's some cases, ways that they've kind of tried to fill the gap. The first one we'll talk about is how. And with this one, you just embed media links or resources in with the request. So with users, you would give them an underscore links on how to get yourself or how to get additional locations. This cleans up a lot in terms of the client having to remember where to request. I don't think it's really a ton better by itself because you still have to do the promise chains in order to get all of the data. And then the next evolution on this, the kind of GraphQL-like approach, is with smart query params. There may be a fancier word for this, but this is where you just make some sort of special query parameters where whenever you send this up to the client, whether it's embedded or includes or whatever, it's going to go ahead and add that data on there. And then you tell it somehow what location attribute you want. And that can be super not fun as well. It's really hard to maintain that over time, especially as your data set changes and your REST APIs change. And I think the last part of this, I think, kind of encapsulates a lot of the problems, is that on the back end, it's hard to deliver the data that you need. I like active model serializers. They're a way to basically take an object and give it to your serializer, and then it returns the data that you need. But inevitably, as projects grow, what I found with active model serializers is that you end up with probably like, 8 or 10 different versions of a user. So, whenever you request an index for a user, you're going to return a slim user. And then, whenever you're returning a full user or a show, and then sometimes you got locations, and this just gets really hard to maintain over time. So getting back to like our original problem, like, from a client perspective, whether it's mobile or from like a spa perspective, like all we really care about is being able to get data from the server and like hydrate our views with it. And we don't have Rails to do that where we can just, grab the data that we need from like a view or a controller or some sort of decorator. So GraphQL gives us a way to specify the shape of the data that we want and then just send that back and have the server do that in one request. But this is like an example of a query that you would send up to GraphQL in order to do that. And it alleviates a lot of those concerns with promise chains and sending too much data or not enough data. It just gives you exactly what you ask for.
Great, thanks, Austin. So I'm just going to cover real quick, some terms and terminology and what, how to make queries. So first off, some quick terminology. A Graph API is defined by a schema, and that schema defines different types. So when you're creating an API for GraphQL, there's really two parts. One is defining what can actually happen and what is really returned, and that's the schema, and then the implementation of fulfilling that schema. These types are exposed through the schemas as fields, and a schema starts with really always having two root types. And here's just the root view of what the Documentation Explorer looks like, and it shows you the two root types, queries and mutations. So anatomy of a query. So this is a query, top level keyword being the query. This is the name of the field that we're going to fetch off that query, profile. And then you can actually embed additional fields that you're requesting. So in this case, I'm asking for a profile and give me the UUID. In our case, in our implementation, this actually defaults to returning the profile of the currently logged in user. Fields can be scalar values, meaning they're strings or just really basic types, or they can be other objects. If you're asking for another object, you have to ask for their fields, right? You can't just ask for an object. You have to specify what you want off of that object as well. So as you can see, here's our query again, and the results look very similar to what you're asking for. As we say in GraphQL, the shape is the same, right? So on the left, you see exactly what you're asking for, and on the right, you can see the shape matches it, right? You have a profile, a UUID, a set of other links, and the data on those links as well. And that's really cool because you can actually, it's really simple to see what your response is going to look like based on looking at the query. You can think of GraphQL types and queries like giant objects, right? An object has fields, a field has a type, and either that type is a scalar value or another object of some type. And for scalar values, your GraphQL defines five: an int, float, string, boolean, and ID. These are the core types of what those end fields could be. An ID is something special. In the end, it's just a string. It's just a special nomenclature to say that this thing represents an ID of an object, but it's serialized as a string. You'll notice that there's no date implementation, and the reason for is dates are just serialized as strings, and ours is just the default Rails date serializer. And so GraphQL provides you the ability to define your own scalar types if you need. We haven't had the need for it, and for the most part, clients just interact and know how to parse dates. There are two special modifiers that you can apply to fields in GraphQL. One is lists, and the other is required fields. So in this case, I'm showing the documentation of a profile with a subset of the fields on it. And, I'm showing other links and UUID. And other links here, you can see that it's going to return a list of links, right? So it's denoted by those brackets, and the type of that list, or what's going to be inside that type, or what's going to be inside that list is inside those brackets. And you can see that here. On the JSON response, other links is an array of objects, which is of type link. And if we actually click through those, the documentation explorer, we would see that link has name and URL, excuse me, as fields on it. So required fields are marked with an exclamation point. It denotes that a field will always have a value, meaning it's not null. So you will not get a null value with a field that's marked with an exclamation point, which is really cool for a couple of reasons. As a client, when you're making a request and you're looking at the UUID, you know that if you ask for the UUID off the profile, you know you're going to get a value back. It will never be null. You don't have to worry about checking null. You know it's always going to be there. And also, as a client making a mutation, if you're sending input in and there's an exclamation part, you know that you have to supply that value. There's got to be something. It cannot be null. And this is really great because as a client, you can't put something on the wire, so you can't make a request without providing these values. It won't even get on the wire. You'll have a schema validation there. And as a server, if you're trying to make a response and you're trying to provide a null value where a field is required, it will also give you an error as well, which is really helpful for implementing and for making requests. So in this case, exclamation where you put the exclamation mark matters. So I implemented this other links on our profile, and I actually forgot an exclamation mark. And in this case, we will never actually reply with a null list of other links. So that needs to be fixed. And as well, link will always be an object. It will never be null as well. So, but just to illustrate this point, imagine if these were just strings and we had an exclamation mark at the end here. So on the left, which of these would be invalid? And I'll give you a quick second to think this through. So the question is which one of these objects or which one of these results, if other links was null or foobar or null foo, which of these would be invalid? And the answer is the first one. We're saying that other links can't be null, but the values inside the array could be null. And to illustrate this, if we change the placement of that exclamation mark, is another example of which of these would now be invalid. And if you haven't guessed already, the first two are valid, meaning that you can have null links and you can have values in it, but you cannot have null values in your list. So another really key component of GraphQL is that fields can accept arguments. And you see this at top level all the time when you're asking for a profile. You're saying, I want the profile with this given UUID. But another place where this is important is any field could accept arguments based on how you implement your schema. So in our case, clinical trials actually accepts several arguments, which you'll see later. One of them is first. And what we're saying here is we want the first 3 results of clinical trials. So we can actually limit what we're asking for and say, I only want the first 3. And there's other options available too. But the key part here is when you're building GraphQL schemas and implementations, this could be anything. Any field you add, you could actually put any argument on there so that your users who are requesting data can do some pretty rich things with those requests. Okay, so a couple more things about GraphQL types. We have what's known as abstract types. The first kind of abstract types are interfaces, and it's really like any other language. They're really meant to treat different types and different objects similarly. In our case, we have several interfaces. One of the ones that are key or that you'll notice is a node interface. And it's really not that special. All it is it denotes an object that has an ID. There's one field, it's required, and that's an ID. In this case, profile implements this node interface, and a node, again, has one ID, right? So we also have the ability to query nodes, right? Which really says that we can make a node query given one argument, an ID, and because it's a node, the only field we know about is ID. So this in of itself isn't that interesting, right? The ability to query for an interface and only get fields back on that interface is only so limited, especially in this case. But where it becomes powerful is with the concept of inline fragments. And what this allows you to do, it's kind of like I think of it as a splat operator. So it actually allows you to fetch fields from concrete types. So in this case, what we're actually querying for is we're saying the same thing. Give me a node with this given ID. So fetch this node with this ID. And if it's a profile, so the 3 dots on profile, so when the type that is being returned is a profile type, give me these fields off that type. In this case, a UUID, other links, URL, and name. And this is what the result would look like. So that's pretty interesting, but what gets more interesting is when you have different types, and this is an example of that. So we have a singular node query, and we also have a nodes query as well, which is plural, which allows you to provide an array of IDs. And on here, I'm saying if the result that's come back is a profile, give me the full name. If it's a clinical trial, pull me back the title, right? And you can see this data result here, which is pretty powerful. I was kind of blown away when I saw this, and we have pretty much all of the entities that you can request in a profile implement this node interface. So and it's actually specifically for the relay specification, which I won't talk about in detail, but it's really meant for refetching. So if you have a given object, you can refetch it and grab the latest version of it at any given time, just based on doing a node query. So this is pretty neat, but again, it's not really powerful. One of the things that makes it make it a little bit more interesting is the concept of aliases, which allows you to say, okay, on a profile, give me the full name, but when you return it to me, I want you to call it name. So in my result, I want it to be referenced as name. And the same thing on clinical trial. If I have a clinical trial, give me the field title off of it, but return it to me as name. And you can see this in the results, right? So now I have nodes with a list of objects where I've requested one field off of them, and now they're unified, right? I have a name of some clinical trial, and myself, obviously, so full name off of a profile. So it's allows you to this kind of aliasing provides you 2 kind of very powerful things. One, it allows you to uniform your results if you need, but 2, it's possible to issue the same query, so you can fetch 2 profiles in the same query, and they can't have the same name. So you can actually name one Ryan and the other Austin, and you get those results back and have 2 different profiles in there. Another abstract type is called a union type, and it allows for returning disjoint set of objects. So these are objects that don't share common fields, but you want to be able to return them as if they were the same thing. We don't do this yet, but a good example of where we could do this is unified search results, right? So if you have profile and news and suggestions, you want to return them all in the same array of something, you could declare it as a unified search result, which is a union type. And basically saying all the possible types that could exist in this result set are one of these types, right? Profile, news article, suggestion. Again, this is just something I made up for this presentation. There are probably other ways we might want to think about this, but this gives you an example of where we could or may want to use union types in the future. Okay, so getting back to pagination. So the GraphQL specification itself doesn't specify how to do pagination. You could implement it any way you want. It's always done by providing arguments on fields. Relay is a specification of itself, and it does specify how to do pagination. And in our implementation, the GraphQL Ruby library that we're using actually provides implementations for this relay specification as well. And I could spend 10 minutes talking just about relay, but I'm not going to because it gets kind of complex and it's kind of an in-depth kind of thing. But what I do want to point out real quick is getting back to that clinical trials example earlier with arguments. In this case, clinical trials actually takes 5 different possible arguments. First and last are saying given some number n, return me either the first n elements or the last n elements. You can request specifically by an ID, or the other interesting ones are after and before. And what these take are cursor values. So you can see in this request, I'm actually asking for clinical trials, a set of edges, and on that edges, I'm asking for a cursor value back. So once I get that cursor value, I could requery and say, give me everything after this cursor value and give me, some number after that. And this provides you a way to do pagination, and specifically in our case, without doing limits and offsets. So I'm going to hand it back to Austin to talk about some mutations.
Cool. Thanks, Ryan. Alrighty. So queries, awesome. It's where a lot of the power inside of GraphQL is. But because we have this domain, it's really not going to be able to provide much value unless we're able to update values as well, whether that means creating new items or updating existing items in our system. And the way that you do that is through this, the second root level entry into our graph, which is called mutations. So mutations, it's just a fancy word for saying, hey, this is a way to change data. Under the hood, this is really just another type of query, but I like to think of it as functions. So, and we name these in a way that makes it very explicit about what it's doing. So locations update, locations create, locations destroy. And those mutations take in values. They perform your mutation, and then you're able to do a query back in order to get data from that mutation. So over here on the right, I have a example of a query for locations, and the query that you make on a mutation has a few ways. They don't have a way to, or sorry, inside of GraphQL, there's no concept of like unprocessable entity whenever you're doing a mutation, or bad data whenever you're doing a bad mutation. All of those things are considered business as usual. So the way that we have defined a way to communicate bad mutations back to the client is through a success key. So if this success key comes down as true, it was a successful mutation, or false is an unsuccessful mutation, and then we provide an errors object, which is really just active model validations. But you'll see like this is the query portion of this. When I go to the next slide, all that a mutation is a wrapper around that query with some additional things that it does. So we're going to wrap our query with this keyword mutation from line 1. We're going to pass it some values. We're going to send it in an ID, an address, and primary. And then we have inputs from line 2 into the location update mutation, which is really just some function that we've created under the mutation entry into our graph. And these inputs have these same qualities and traits that fields do on the query, in the sense that you can mark them as being required or of a specific type. Um, that provides a lot of power from the client perspective because a lot of the times before I even send a mutation up, like the actual data up, I can know whether or not that is valid. Um, So some of the main differences with like REST for mutations, you're able to specify the data that is returned in that query. Where that is different from REST is a lot of times you don't know if it's going to return like a full object back or just success or just okay keyword or whatever, and you're not going to have to do promise change. You send up a mutation with a query and it's going to send it back to you. Something to keep in mind is whenever you're doing these using Apollo, which is the GraphQL client we use, whenever you're doing these in the query back, you have to request the ID, and then it can do some cool stuff for you automatically for updates. The mutation errors are considered a part of the schema. So errors inside of your mutations are business as usual. You don't convey that with a 422 response or even like a 400 response. It is just a success or failure, and that's something that we've defined ourselves. Um, and then a lot of times you can know if something is a really invalid query before you send it up, and that lets you do some really rich client-side validations and not bug the server whenever you know that something's going to just fail if you send it up anyway. So, apiary. I do not love apiary, and I bet if you ask somebody like Fabio if they liked apiary, they would get a similar response. Um, something I found with REST is that documentation becomes really hard and unreliable because most of the time it's something that's done after the fact, kind of like how a lot of testing was done after the fact, if at all, before people started embracing more of a test-driven design approach to that. So over time with documentation, it becomes brittle and unreliable, which makes it just really hard to rely on. But with GraphQL, documentation is really easy because whenever you're defining that schema that Ryan was talked about with mutations and queries and all of that stuff, it's all strongly typed. So all of the documentation happens automatically. And there's a open source utility called GraphQL that allows you to easily navigate through all of the documentation. And we've taken a couple of screenshots here of like some examples of that. So over here on the left, it also provides you like a playground where you can easily interact with the data. Using the client that we're using called Apollo, it gives you the ability to replay these mutations and queries so that you can see exactly what's going to happen whenever you make requests. Um, a lot of really great features in this graphical thing. So syntax highlighting, you can get types, and then autocomplete is really incredible for this. So like if you start typing under profile, you type an L, it's going to give you a few options to select from, like last name. Um, and then here's a GIF of Ryan just kind of going through some of the documentation. And keep in mind, we did not generate any of this documentation. There was no command to do this. We just defined the schema, and this all exists from here. Over on the left, you see a bunch of fields and scalars, and on the right in yellow, it is the type that they are. So either like that one's a string, the last name's a string, so it's a scalar value. It's something that's going to be returned. And then over on the left now, it shows you kind of how like that syntax or the autocomplete works, and then the request from that. Okay, back to you, Ryan.
Yeah, great. So talk real quickly about GraphQL-Ruby and the Ruby implementation, what we're using to actually serve up our GraphQL library. So again, GraphQL is a specification. It's not an implementation. And so obviously, if you want a GraphQL API, you have to implement the specification. So to do that, we've used the GraphQL-Ruby library. It provides most of what we need in order to generate pretty much everything you've seen. It provides you the DSL to actually create the schema, generate the schema, and actually how to serve and validate pretty much everything. What we need to define is actually the types and the business logic on how to fetch fields, right? So it's a very extremely rich library. It's a bit unique when you go to look at it and how to use it, mostly because it's written very in a very functional way. So uh, one thing to keep in note is that the types and field definitions on these objects or on these in this GraphQL API, they're lazily evaluated. It's kind of like Rails loading, but it's done differently in its own way. Just something to keep in mind as you're working with it. Hasn't been any issues, but every once in a while some things crop up. Everything's done through some sort of callable. So, blocks, stabby procs, either a class with a top level class level method with call. And you can see that here on the right. So this is at the top level, a subset of our query, right? These are the fields. This is our query. This is of the two root types. One was query, one's mutation. This is what is at our top level query. And I've shown a couple of things here. One, these are the node queries, right? So node and nodes, this is actually implemented for us from the library itself. So all we did is expose this, and now we can make node queries on our library. So anything implementing that node interface. Country. So this is something we expose. This is how we do country lookups. And what you'll see here is that, first of all, it's provided a block with the DSL, right? So you provide an argument or arguments, any number of arguments. So this field takes a key argument. And as you can see, the type of that key is a string. And with the exclamation mark, it's required, right? So this is a required argument to the country field. And what's pretty cool about this is the documentation is inline. So we talk about that documentation that's free. Here I'm saying that this key is really some documentation here that says this is an ISO alpha 2 country code to look up the country by, right? And then finally, there's a resolve proc. And this is what actually does the work, what will be invoked when the library is peeling off the query and identifying that the country field is what the user is asking for, right? In this case, it's going to call this proc with 3 arguments. I didn't expand them here, but what happens is it gets past the top level object. So if you're in the middle of a nested query, let's say you're on profile and you're fetching a the clinical trials, then this first argument would be the profile. The second argument is the args that are passed to that field. In this case, we have a single required field, so there's going to be key in that array. And the third one is a context object, which is kind of like a session, but it's something we set up and control. And it's passed down all the way through the graph, so you can access some top level things. Let's see here. So yeah, so on the left, I've showed the documentation for country. So this basically is if you go look at our query on doximity.com, you'll see that you have country, it's single key, a single argument with key, and it's a required string, and it returns a country type. And here's our country type real quick. It shows you, it implements the node interface. It has a single field key that you can pull off of it. It's got other fields. One's a name. It's mapped to property. So, and this is a quick way to say, I'm asking for name, but really what you're going to invoke on the country object that's underneath me is the friendly name. And the same thing with abbreviation. So one of the things we've done in our GraphQL API is try to name things from a client perspective. Everyone knows underneath the hood, sometimes we have some odd naming things and doesn't always work out. What we want is the API to make sense to somebody looking externally. So in this case, we've taken the time to rename these 2 fields so that the name of the country is actually the abbreviation, which is what it is in the database. And I'm going to pass it back to Austin to talk about some other things here.
Okay, thanks, Ryan. So yeah, I mean, there's no silver bullet with really any technology. And here are some of the downsides that we've found with GraphQL. I'd say like the biggest one is that the base implementation that Facebook provides is in Express.js. And a lot of other languages use that as a point of reference to try to translate those concepts into other languages. So Ruby is really a second-class citizen to this like Express implementation. But I would say like out of all the other ones that I've seen, it's the one that's I guess more maintained and closest to it. And a lot of that has to do with the gym owner. Like he's a member of GraphQL core, and also some React stuff. And he's a pretty smart dude, also employed by GitHub. I think we're trying to hire that guy. If anybody knows anybody that could reach out to him, that'd be great. And it's also more of a functional style, so that can be a little disjointing at first if you haven't done more like service object oriented type programming before. Also, with GraphQL, it's just a specification of how your API should work. So it's the front end part of that. There's no community consensus on any of the standards, and a lot of this stuff, we've already rolled a lot of it on our own, but most of it's going to be a roll your own type approach to it. And coming from like a really heavily conventional application framework like Rails, that can be a little hard to get used to at first. And then something that we're actively trying to figure out right now, mutations aren't namespaced in a painless way. So I mean, you can namespace them, but it becomes pretty painful to do that. So right now we've just got everything like flat. So like, you call like locations update. And I mean, it's been pretty okay so far, but we have like, probably 20 different types of things that you can do on profiles. And then most of those have like a create, update, and destroy. So we know like 50 or 60 ways that you can enter in. I don't know if that's going to be a big deal long term, but that's something we'll probably want to look at some point. All right, so can we get back to you, Ryan?
Yeah,
Oh,
so that pretty much wraps up the
okay.
presentation.